some problems like will be on your quiz, okay? So I'm going to start with the ones that are easy to write down. Those word problems are easy to write down, but some of these are easy to write down. You are going to have to be able to calculate something like this or something like this by hand. All right, so dig back in your memory, look in your notes. Maybe it's be a good exercise to look in your notes. We did this. Now, for the quiz, I'm not going to put any n's in it. It's going to be all numbers. Remember in the notes, we actually did some with n. Remember that? You guys are like staring at me blankly. We did this, I promise. Okay, so who remembers the like little formula thing? How do we set this up by hand? 8 factorial, not just 8, but 8 factorial over 6 and also over 2. Remember, when it's a C, what does C stand for? Combination. When it's a combination problem, it's this number on the top, factorial, this number on the bottom, but also the difference on the bottom. Okay? So then you're going to have to calculate this without a calculator, so by hand. Remember, 8 factorial means 8 times 7 times 6, 5, 4, 3, 2, 1. But that 6, 5, 4, 3, 2, 1 is going to cancel with this, isn't it? And so all I have left is the 8 and the 7 over the 2 and the 1. Does everybody get how that part's going to cancel out with all that part? So that's 56 over 2, which is 28. So the answer would be 28. Now, who remembers that now how we do P's, which stands for permutation? Who remembers that? Sir?
Wouldn't it start off the same as 8 factorial over 3 factorial? Like, wouldn't it start the same?
Actually, no. When it's a permutation, it starts with the 8 on top. But then the only thing in the bottom is the difference. In a permutation problem, you don't have the second number. All you have is the difference. So we can cancel the same way. 8, 7, 6 won't the 5 go away with this stuff down here? All that's gone. So your answer will be 56 times 6, which is 336, I think, if I times right. So if you don't remember those little formula things on how to set these up, study it. Okay? Now, I'm also going to put on the quiz some problems where you don't have to do anything except tell me if it's a permutation or a combination. So what's the difference? Sir?
Permutation order matters, combination order does not.
Exactly. So you read the problem, it'll be a word problem, and you'll just decide, okay, does order matter or not? All right? So let's say that I have 10 students in my club, and I have to pick a president, vice president, and treasurer. Is that going to be a permutation problem or a combination problem? It's a P. It's a permutation because these jobs are different, right? So it matters if I pick Abby first or if I pick Gavin first. It matters because whoever I pick first is going to be president. That's a permutation. This would be actually 10P3. Anytime you have a big group and you're picking a few out, it's a P or a C. It's a permutation or combination. If the order matters, it's permutation. So this would be a permutation problem. Now, same scenario, 10 students, but I'm picking a committee of 3. That's a C. Because if I'm picking 3 people to be on the committee, Does Gavin care if he's first or pick first or last? No, he just wants to get picked. There's no jobs assigned. Okay, speaking of which, almost forgot. We have some play people in here, and I always make cookies once a year for our play participants. So we have Alexis isn't here to enjoy it, but we have Sir. And did anybody else do anything in any of the other theater performances this year? Everybody here, cookie, not just Sir. Well, anyhow, good work, theater department. You don't have a championship, so they'll just celebrate the musical. All right, let me do another one. This is what made me think of that. Suppose I have 10 actors in the room. And I need to pick 4 of them to play the Beatles.
The Beatles?
The Beatles.
Oh, as in the group. Yep.
P or C? P. Because it makes a difference if I pick him for Ringo or if I pick him for Ringo, right? I can pick the same 4 people, but they have different jobs. They're playing different people. Now, in the old days of cathedral theater, the cast of the musical was gigantic because everybody who tried out got a part, got to do something, no matter what. Everybody got to do it. So you would go to the play, and there would be kids playing trees and bushes.
And tree roots.
And yeah, whatever. So, suppose I have 10 actors, and I'm gonna pick 4 kids to play bushes. They're gonna dress up in green and be a bush. That's a C, because they're all doing the same thing. Doesn't matter what order you pick. So if the jobs are different, then you're a P. If the jobs are the same, then you're a C. Got it? Okay. Another problem you're going to have is something like this. I call them the jumper shirt problems. Suppose that you have to pick an English class and you have to pick a math class to take next year. Okay? You gotta pick both, sorry. You have to take an English class too, I'm sorry. So there are 6 English classes to pick from and 8 math classes to pick from, and you must pick one of each. How many ways can you do that? Sir?
Would it be 9C2?
No. And I'll tell you why. I get what you're doing. 9. How'd you get 9?
6 plus 3?
Oh, that's an 8. You probably can't see it because of the glare.
Can't read.
But,
He doesn't have glasses.
but
I don't have
that's
glasses on, so.
14. I get why you're saying 14 choose 2. But if we put all these 14 together
Yeah.
and pick 2 out of it, would it be possible to have 2 of them be English classes, sir?
Yes.
Yes, okay. So, we don't want to do that.
Are they like the same classes? The same math class?
No, different math classes.
Would you have to take out one math class, one English class, and group them together?
Well, that's what we're doing. We're choosing one math and one English.
Oh, multiply them.
How many choices do I have for a math class? 8. How many choices do I have for an English class? 6.
Then divide.
How many choices do I have altogether? 48. 48. I can pick an English class 6 ways, and I can pick a math class 8 ways. I can do them together 6 times 8. Think about this. suppose one of the English classes is Shakespeare, right? Here are your 6 English classes, okay? One of them's Shakespeare. You can pick Shakespeare and then pair that with 8 different math classes. So you can take Shakespeare 8 ways. Well, what about, I don't know, Romanticism? How many ways can you take that? 8 more ways? So wouldn't there be like 8, 8, 8, 8, 8, 6 8s? 6 times 8. 48. It's the fundamental counting principle. If I have 10 jumpers and 12 shirts, how many outfits do I have? 10 times 12. I have 10 choices of jumper, 12 choices of shirt. Same principle. Got it? Okay. And then, let's see, I need one more problem for the quiz. Let's try, oh yes, let's do this, because this is easy, you know how to do this. Let's take the word mathematics. Don't worry, I'll spell it for you. And let's figure out how many ways we can arrange the letters of that word. How many different ways can we arrange the letters of that word? Abby?
Can you do the 11 exclamation mark over like the amount of like doubles?
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11.
And
Let's say the real word for the exclamation mark. What is it?
I don't know.
Factorial. So we're going to take 11 factorial and we're going to divide that by, what did you say, Abby?
Like the repeats, like there's like
2
2 M's.
M's. And I like to keep track of our M underneath. So 2 M's. What else? 2 A's.
2 T's.
2 T's.
That's it.
I have HBICS. Yep, that's it. Now, this is going to be a no calculator quiz, but I'm thinking now, but who knows. So let's practice typing this in. You wouldn't have to evaluate this without a calculator. You just set it up. So 11 factorial. Everybody remember where that is, right? And then, since you got all this in the bottom, if you're going to type it all in at once, you got to put parentheses around there. And you should get this answer, 4,989,600. So 4,989,600. So make sure that's what you get so that we're sure you're typing it in correctly. Typing it into, the calculator correctly. Got it? That's it. Okay, so that's where our little quizzy poo will be over. Those kinds of problems, okay? So now, we're going back. We just had begun probability last time, and so we're gonna deal a little bit more with some probabilities and different kinds of probability. But we're stuck kind of in the middle of all these card problems, so let's do some more. Keeping in mind that we need to be a little bit familiar with our cards. So we can find the probability of being dealt a 5-card hand with no aces, no queens, and no 5s. All right, tell me what you remember. Do you remember anything? Abby?
The denominator has to be 52 to 5.
Bingo. Because there are 52 total cards, and I am picking 5 of them. This is problem I. In section 9.3, number 2, right where we left off last time.
Then you would do 52 minus 12.
So 40,
Yeah.
C5,
Yeah.
And why did you say 52 minus 12? I mean, to get the 40, why did you say that?
Since we're not doing aces, queens, or fives, that's four, there's four of each one, so you
We're gonna
like,
pull it
take
out,
those
right?
Yeah.
If I don't wanna pick those, don't I wanna pull those out? So, I think he's exactly right. Let's type it in and see what we come up with. Always, when you do these, guys, be on the lookout for that scientific notation. I don't think it's gonna happen in this problem, but it happened in a lot of our problems the other day, if you recall. Oh, no, we got a good answer here. Did you get 0.25? 32?
2, 5, 3, 2, yeah.
So basically, there's about a 25% chance that if I dealt you 5 cards, you wouldn't get any of these things. No aces, no queens, or no fives. All right.
Sorry.
Now we want to be dealt exactly 4 spades. Okay, tell me what you know about that. Exactly 4 spades. Izzy, hand up.
So 4 suits, so it would be 52 divided by 4.
You mean to figure out how many spades are in the deck?
Yeah.
Absolutely. So there's 13 spades. All right, so what do you want me to do with that 13?
Would be 13C5
So, where?
on the numerator.
On the numerator? 13C5. Now, I love the 13 because she's picking spades, right? But what's a little bit amiss, Jeff?
Well, you want, you only need 4.
I want 4 spades, Izzy,
Um,
right? So that's gonna be 13C4. All right, so far so good. Everybody with us?
Mm-hmm.
Perfect. All right, yes, Donovan?
Would it be 52C4?
Where?
Denominator?
Okay, it would be 52C4, except it's a 5-card hand. And I didn't put it in the question specifically, but it's in the major directions, you know, for number 2. These are all 5-card hands. So my denominator is gonna be 52C5, because it's a 5-card hand. If it were a 4-card hand, it would be 52C4, but it's a 5-card hand. Now, something is not quite there yet, folks. What are we thinking? Abby?
Is this where you have to multiply it by 48C1 over the 52?
I'm gonna multiply it by something. It's not gonna be 48C1 this time, but it's something. Tell me what are we trying to do? What are you trying to get?
Oh, when I subtract all the spades. so 52
Exactly.
minus 13.
We don't want another spade. So it would be 39C. So what Abby is saying is that this is a 5-card hand. If 4 of them are spades, don't you need another card? And the other card cannot be a spade. So she said, all right, take the spades out. There's 39 cards left. So I'm gonna pick one of those non-spades, diamond, heart, or club, and then my 4 spades. Does that look okay to everybody? All right, let's type it in. Okay, you're ahead of me. Just a second.
Wait, but can't you have 5 spades just because there's 13 of them?
You definitely can pick 5 spades, but the problem says exactly 4 spades. So I wanna have a hand that has exactly 4 spades.
So not 5 spades?
Not,
Okay.
5 spades wouldn't be exactly 4.
That makes sense.
Yes, it does. Now, Reese, read question K.
At least.
What does at least 4 spades mean?
That's card one, be a
You
spade.
could have 4 or 5. So this is actually gonna be part of the answer. This is the answer for J, but it's gonna be part of the answer for K. Does that make sense to you? Because if you have to have at least 4 spades, you can have 4 spades. But what else can you have? You can have 4 spades, or you can have 5 spades. And what will 5 spades look like? 13 C5. So you can have 4 spades and something else, or you can have all 5 spades. Okay, so I can type that in. Okay, this is one of those scientific notation answers. So 4.952 times 10 to the -4. Now, I need an answer. I've got this answer sitting right here, and I've got this, this is the probability of 4 spades, this is the probability of 5 spades. What am I gonna do with those 2 numbers? Sir?
Add them.
Add them. See this right here? That always means add. So I'm gonna add 0.0107. And I got an answer of 0.0112.
Could you, like, I'm just thinking, if you already have, with the one before, said J set up, and then you're just like, could you add back the spades to the, like, the second C thing? And then just do that, and get the same answer? Because you can since that 5th card can be a spade, can you just add 13 back to 39 and just do 52 C5 on the top?
No. On the top?
Yeah, so because the fifth one could be a spade, so you have all spades.
Okay, but if we had 52 C5 on the top,
It'll cancel.
yeah.
So then you just can't do anything like that?
No,
Okay.
when you are doing at least 4 spades, it's 2 cases. There's no way to shortcut it.
Okay.
You do 4 or 5 and add them together.
Okay.
What is the probability of being dealt at most 4 red cards? All right, now, think about this for a second. We're almost done with the card problems. I know they're getting bored with them, but we're almost done with them. So think about this. You're gonna get 5 cards. And you want at most 4 red. So what does that mean in words? At most 4 red. We could have
4 or less.
4 red, or we could have 3 red, or we could have 2 red, or we could have 1 red, or we could have no red. Would you agree with that? Now, were you listening to the conversation Sir and I were just having? You don't shortcut this. If this is how you're gonna set the problem up, then you're gonna do this case, this one, that one, and add them up. It's definitely doable, but it takes a long time. Let's think about it for a second. There were 5 cards in the hand, right? This is what I want. All of this is what I want. What is the only other thing that could happen? If I dealt you 5 cards, what is the only other thing that could happen that's not in this? You could get 5 reds, right? So if we find the probability of what I don't want, the only thing I don't want is all 5 red. So if I find that probability and subtract it from 1, that will be all of that added up. Does that make sense to you? All these have to add up to 1. So if I do 1 minus this one, I'm gonna get all that. Okay, so what's 5 red gonna look like? Probability of 5 red. What? 26 C5. Why 26?
Half the deck.
Is half the deck is red over 52 C5. Now this is the probability of getting all red. So we'll subtract that from 1, and that will be the answer to our question.
You said subtract 1.
subtract it from one.
Oh, okay.
I got 0.9747.
Mm-hmm.
All right, everybody okay with that? Now, we have the doozy problem. What is the probability of being dealt 2 of one suit and 3 of another? 2 of one suit and 3 of another. So give me an example, what does that mean?
2 spades and 3
Okay,
hearts
so let's look at it specifically. It could be 2 spades
and 3 hearts.
and 3 hearts. All right, so let's find that one. Let's find that probability. I know that's not what it says, but is this part of the answer?
Mm-hmm.
It's a case, right, within? So let's go ahead and find that. What would this look like? 13C2 times 13C3. Now remember, if we want spades and hearts, we gotta multiply. Shirts and jumpers. English class and math class, we multiply options when you're picking both. All right, so let's go ahead and just figure out what that is. Ooh, I got kind of a little number. I got 0.00858. I'm gonna go ahead and write that. 0.00858. Is that what you got? Anybody else get that?
Can you times that by 3?
Times it by what?
3,
Okay, why 3? You're gonna times it by something. Why 3?
because it's in the rest of the suit.
Okay. So Donovan is on the right track. We just randomly did 2 spades and 3 hearts. What if we did 2 diamonds and 3 clubs?
Wouldn't it be the same?
Wouldn't it be the same? So all our situations, all of our suit arrangements here are gonna be the same probability. Would everybody agree with that? So Donovan suggested we times by 3, but I think there's more than 3. Let's think about this for a second. How many suits are there? 4. And in each of these cases, like this one and all the rest of them, I'm choosing 2, right? So there's 4 suits and I'm picking 2 of them to put into my problem. Now, that's gonna be 4P2 or 4C2. Be really careful. Because I am picking a different number of cards, order matters. Because 2 spades, 3 hearts is different, a different hand than 2 hearts, 3 spades. So I'm gonna take this answer right here and I am going to multiply it by 4P2, whatever 4P2 is. Now, for some of you, what is 4P2? 12. For some of you, it might be easier, and it's certainly an option, just to write out all the things. Like, here's one, write them all out. And there would be 12 different ways that you could have 2 of one suit and 3 of another. So actually, Donovan, you were right on target, but then we're gonna multiply by 12.
Question.
So 0.103. Anybody else get that, 0.103?
Yeah. So then, like, if a problem like this, like, kinda happens, wouldn't you just multiply, like, this 0.00858? And then you would have to do, since like, it's like a 2 spades and, like, 2 of something and 3 of something, could you multiply 2 times 3, and then because you have 2 different suits, multiply that by 2, which will get you 12?
No, this 2 and this 3 don't have anything to do with this.
Okay.
Yeah, because if I were picking 7 of these and 5 of these, I would still be multiplying by 4p2,
Okay.
okay? Now, what I want to make sure you get though is, this is a tough problem, no question about it, this is a toughie. What if I were doing 6 card hands and getting 3 of one suit and 3 of another? Now think about that for a second. Now, would 3 spades and 3 hearts look any different than 3 hearts and 3 spades? No. So since I'm picking the exact same number of each suit, the suits are the same. Order doesn't matter. So that one I would multiply by 4c2. Because the order I choose this is choosing my suits. And the order I choose them doesn't matter, if I'm picking the same number of each. Tricky problem, for sure. All right, well, you're all just staring at me blankly. Let's see, we got a Venn diagram here. Everybody's seen a Venn diagram before. So let's see if we can use this Venn diagram to answer some questions. All right, so when we set up a Venn diagram, what's happened in this class, I have surveyed, there's 30 kids in the class, and I have surveyed them, and I've said, okay, how many of you like Twix, how many of you like M&Ms, and we counted, and this is what we came up with. Okay, 30 kids in the class. All right, how many like M&Ms? 17, beautiful. How many like only M&Ms? 11. How many like M&Ms and Twix? 6. That's the football in the middle. Those are the kids that do both. How many like M&Ms or Twix? Now, before you answer that question, I want you to read question E. They are different questions. So make sure that you're reading D with an open mind. How many like M&Ms or Twix? 26. 26. The answer to question D is 26. Do these people like one or the other? Yep. Do these people like one or the other? Yeah, they happen to like both, but that's still one or the other, and so do these. Now, how many like only M&Ms or only Twix? That would be 20. They only like one kind of candy. How many don't like any of this candy? How did you figure that out?
There's only 26.
Because there's only 26 people who voted, apparently, when I asked the questions. And so 4 of them didn't vote. All right, now you're going to build your own Venn diagram. Same situation, we got 28 kids in the class. And we're going to ask them, okay, do you like jazz or do you like country? Or both. All right, so each of the 28 students in the class likes jazz music, country, or both. So everybody is in the circle. So there's 0 out here. It says each kid likes something. How many students like only jazz? All right, when we voted, in come the 28 kids. Hey, how many of you guys like jazz? 18 hands went up. How many of you guys like country? 14 hands went up. That's what's happened. Now fill in your Venn diagram. Tell me what you notice. You notice anything? What do you notice? Izzy?
There's no like people, it doesn't specify if anybody likes both.
Right. So I have to figure that out. how can I figure that out? Do you notice anything about the situation? Julian?
18 plus 14 is 32.
Oh no, 18 plus 14 is 32. What's the matter with that?
That's more than.
There's only 28 kids in the class, but remember what happened? They walked into the room, hey, raise your hand if you like jazz. 18 of them raised their hand, okay. Raise your hand if you like country. 14 raised their hand. So 32 hands went up, but there's only 28 kids in the class. What happened? Some of them voted twice. Those are the kids that like both, Izzy. How many kids voted twice? 4. They're right there. There are the 4 kids that voted twice. Remember, everybody voted. So there's nobody out here. So everybody voted. Now, 18 kids voted for jazz. 4 of them have already been counted, so there are, wouldn't it be 14 here?
Yeah, just give me that.
And then 14 voted for country, so there'd be 10 here. And now we can answer the question. How many students like only jazz? 14. Okay, so did this make sense to everybody? All right, now we're gonna do another Venn diagram, but it's gonna be bigger. Because now we like Fords, Buicks, or Chevys. So now our Venn diagram has a Ford circle, a Buick circle, and a Chevy circle. And there are 32 kids. And when we took a vote, I said, how many people like Fords? And 19 people raised their hand. And 19 raised their hand for Buicks, and 12 raised their hands for Chevys. Now, those numbers can't go in here yet. Because when we say 19 people like Fords, that's this entire ball. And that ball's divided up into 4 parts now, okay? Well, what can we fill in? Let's see. 5 kids liked all 3. Isn't that these people right here? So that's a 5. 6 like only Fords. Here. 3 like only Buicks. And 2 like only Chevys. Now, what do you think? Are we okay so far? All right. I cannot answer any of the questions until I get all the rest of these sections filled in. Anybody have an idea? Julian?
Would you do, so like for the Ford and Buick and those two, would you do like 19 plus 19 for like on both the sides, and then do 6 plus 3 plus 5, and then do 19 plus 19 minus.
Okay, I love what you're thinking. The problem is, in this problem, we don't know that everybody voted. We don't know that there aren't kids out here. They have to be accounted for. So I love your thought process. What if, I mean, the real deal is, I don't know what these 3 sections are. So what if I call them X, Y, and Z? So X is just that little section right there, and Y is right here, and Z is right here, okay? Now, tell me what I know about 6 and X and 5 and Y. What do I know about those 4 things? 6X, 5Y. What do I know about them? They add up to 19. So 6 plus X plus 5 plus Y is 19. So that means if I simplify that equation, X plus Y equals 8. Yeah. Is that okay with everybody? That's you. We good? Now, can we do the same thing for the Buicks? Alright, so I'm gonna hang on to this equation right here. Okay, so the Buicks say X plus 3 plus 5 plus Z is also 19. So X plus Z is 11. And then might as well do the same thing for the Chevys. So Y plus 5 plus Z plus 2 is 12. So Y plus Z equals 5. You okay with that? Now what we've got here, if you look at my boxes, we have a big system of equations. This always works out beautifully. So I just want to show you the quickest. I know you can do this on the calculator, but it is so much quicker to do it by hand, and it always works out this way. Let me take my first two equations. I can take any two, I'll just take the first two. And I'm gonna multiply, these are my first two equations in the boxes there. I'm gonna multiply the bottom one by a negative. So what will I be left with if I do that?
Y plus Z.
Actually, Y minus Z equals negative 3.
Yeah.
And then see this one right here? It says Y plus Z equals 5. Well, what's gonna automatically happen when I add those together? The Z's are gonna be gone, and it's gonna say 2Y equals 2, which means Y is 1. So this little guy right here is 1. Well, wait a minute, if Y is 1, what does Z have to be? 4, so this little section is 4. And if Y is 1, what does X have to be? 7. And now I know everything I need to know. So getting these three equations, I think everybody followed that. I just picked two of them and eliminated their common letter. So in the case of these two, it was X. That left me with an equation that matched up perfectly with my third equation. I eliminated again, and then I had my answers.
So then, since we have, well, most parts, does that mean 4 kids didn't vote?
I don't know. I gotta add all these up. What do all these add up to?
28.
These add up to 28? Then yeah, 4 kids didn't, they don't like this, any of these cars. They didn't vote for these cars. Because there's 32 people in the box, and apparently, there's only 28 of them in the circles. All right, let's answer the questions. A student is chosen at random. So I reach into the box, which has 32 kids in it. I reach into the box and I pull a kid out. What is the probability that he likes both Chevys and Buicks? Now, be careful. It doesn't say only Chevys and Buicks. It says he likes Chevys and Buicks. Where are the people in the picture that like Chevys and Buicks? Where are those people? Aren't they right here? Chevys and Buicks would be the overlap of the Chevy and Buick circle. How many people are in there? 9? Jeff?
Couldn't you add in though,
We like both Chevys and Buicks.
I don't know,
Yeah, so the F circle is a part of the conversation. We're looking at this circle and this circle, B and C, and they overlap right there in that football. 9 people, but that isn't the question. It says, what's the probability? So what will the probability be? 9 32s. Yep, 9 over 32. So the answer to A is 9 over 32. Your probability of getting one of those kids is 9 over 32. How about what's the probability of getting somebody who doesn't like any of them? 4 over 32, which actually reduces to 1/8. Because that's 4 out of the 32. Okay? All right, well, you're doing great. I know you're getting a little bit wiped out, but that's okay. It's all right. We're gonna try one more, and I'm gonna have you see how far you can get with it. All right? So I want you to try problem B. And I want you to see how far you can get. This is gonna be just like this one, only your balls are gonna be labeled green, purple, and yellow. Did everybody get your basic starting setup to look like this? So we had no questions about that. And then did you go ahead and call these XYZ or ABC or something? Your labeling might be different than mine. No big deal. We're gonna get exactly the same picture in the end, so don't worry about it.
sorry, Lauren. Are you getting a fraction?
I shouldn't, I haven't done it yet. I'll do that right now. We should not get a fraction, because there are problems where you can get fractions, but not this one, because these
We're dealing
represent
with
people. Right, so we wanna make sure they're whole numbers. So, let me see what I come up with. And your Z might be different than my Z too, the way you identified it,
Okay.
but that, we still shouldn't have that happen, so. All right, so for this section right here, the green purple section, I got 10. That could be a mistake, let me just keep going, that was Y. So for Z section, I got 3, for my Z section. And for my X section, I got 12. Now, I'm gonna double check by adding all this up. So that's 27, and 10 is 37, and 6 is 43, okay, so that works. 12 and 16. Oh wait, no, 7 and 16 is 23, and 20, 32. I think I got the right numbers, sir. Yep.
Do you mind for the like X plus Y and the Y plus Z formula, just you write out the long one so like you know how you calculate?
What do you mean now?
Like the.
Oh, no, that's fine. Yeah. Oh, you want me to write it out?
Because I don't.
Okay, I'll do the first one,
Yeah.
and then they're all the same, but now I'm in trouble because I can't remember what was what. I think this was Y, and this was X. So every number in the G ball has to add up to be 43. So 15 plus Y plus 6 plus X has to be 43. So that's 21. So X plus Y has to be 43 minus 21, so that's how I got the 22.
Okay, thank you.
Okay, so that was 10. And this was 12, I think. So we can answer the question, can we? Reach in. Oh, wait. What do these add up to? 61. So there's 7 people on here this time. If one student is chosen at random, what is the probability that he will like at least one color? At least one color. What do you think? 61 over 68, very, very good. Because the only people that don't like color are those 7. Everybody else likes something. Got it? All right, I told you I'd stop, so I will. I know, no, please keep going, Miss Ford, keep going. We want more math.